Hello, 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 hello. Hmm. So last time we have discussed this one, no? Just things in series in parallel. Acha, I gave this question to you as a homework. Did you try it? Haripriya, Radhika, did you try this question? Hello, 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 hello. Am I audible?
Yes,
Now,
sir, you're audible.
did you try this question? Did you solve it?
No, sir.
Try it now. I've completed conservation of energy and everything.
Sir, could you do it?
See how this will be done. A small mass M starts from rest and slides down the smooth spherical surface of R. I was trying to draw the circle. Like this. This is mass M. This surface is smooth. The radius is R. Assume zero potential energy at the top. Here the potential energy is zero. Means they have taken this as the reference point. Find the change in potential energy, the change in kinetic energy. The speed of mass is a function of the angle theta made by the radius with the mass with the vertical. Okay. this case. Okay. Now, what is happening? See, if the change in potential energy they want, here, if you take this point, if you take, this is the Earth, suppose here is the height h2 and this is the height h1. So in that particular case, this difference will be what? This difference will be your h1 minus h2, right? And they have given this has moved by an angle theta. So this will be what? Actually, this whole distance from here to here, this distance will be, this is also radius. So this will be r cos theta. No, here to here, this distance will be r cos theta. This is total r. So this h2, h1 minus h2 I can write as r minus r cos theta. Correct? So what is the change in potential energy? Change in potential energy is mg into h1 minus h2. So it will be mg into r into 1 minus cos theta. Okay.
I'll write it in variables itself.
That's all. Because they have given only these things, na? They have given only radius and the angle theta. So we have to find out the change in potential only in the case, only in terms of r theta. Okay. Now we have to find the change in kinetic energy. If you apply the conservation of energy here, because see, we can apply the conservation of energy here because there is no work done by except mg. Mg is a conservative force. So here is a normal reaction. Here normal reaction is there, but this normal reaction will get cancelled because this is on this, on here also normal reaction will be acting, so they will be cancel each other. So normal reaction won't do any work, and there is no friction also. So the conservation total energy we can conserve. So here mg h1 plus its kinetic energy half m u1 u square at this position will be equal to mg h2 plus half m v square velocity at this. So mg into h1 minus h2 will be equal to half m v square minus u square. This is the change in kinetic energy. But mgh1 minus h2 is mgh r cos r mgr into 1 minus cos theta. So change in kinetic energy will be same, mgr into 1 minus cos theta. Okay. But they have given it starts from rest. So the initial velocity is 0. So it will be, in putting this in the equation, we'll get half mv square is equal to mgr into 1 minus cos theta. So v is equal to root over 2gr into 1 minus cos theta. Got it?
Yes.
This is how we solve this question. Emma, what is this you are doing?
Sir, I'm not having network, sir. I have network issues.
Hmm. Yesterday also you had network issue.
Yes, sir. Like, no proper net.
Did you solve this question? The question I gave as homework.
Um, yes, I guess. So we solved it in school, I guess. The
This one.
same question. The same question.
See, in the last class also I gave you one question. When I asked you the answer, you did not have the answer. Either you have the answer. If you have solved it, give me the answer quickly. If you do not have the answer, then solve it in the class.
Okay, sir.
Because again, if the same question will come, if again the same question will come in your examination, and then you will tell me, sir, I could not solve this type of question, then it will be problem. It should not happen again.
Okay.
If you know it, you should get the answer quickly. If you do not know it, try to solve it. That's all. Acha, now I'll give you more questions. Try solving it. Can you solve this question?
Yes, sir, I could.
Tell me.
Um, 1 second, so I'll solve it and let you know.
Haripriya, Radhika, Kanishka, just read the question and then tell me what concepts you will be applying to solve the question. Don't look at the solution in internet. If you are doing it, very bad practice.
So we have to use law of conservation of momentum and solve.
Why?
Because the particle is being split into two pieces, so m will be m by 2.
Then why we are applying the law of conservation of momentum here?
Because the initial momentum is equals to the initial momentum by the block will be equal to the final momentum. Sir.
That's what the law of that's what the law of conservation of momentum is that.
Sir,
Shama,
I got 36/4.
no, tell me the answer. I am asking why we are applying law of conservation of momentum here.
Uh, because a particle is being split into two pieces and it is moving in the same direction, and then because the mass and velocity is being like split into two, I guess. Not split into two, it's like changing, I guess so. But I use law of conservation of momentum to get the answer.
Anyone, what is the condition for applying the law of conservation of momentum? Ask me
There
this.
should be change in the there should be change in the kinetic energy.
No. That's not the condition.
Velocity must be
No. Anyone. Radhika, Kanishka, anyone. Or Haripriya gave me the wrong answer. Similarly, Shama is also not able to give me the answer. He just know that we have to apply the momentum, conservation momentum. But why? Do you know? Do you remember the necessary condition for applying the conservation of momentum?
work done must be
No,
changed
wrong.
in. I'm not sure.
Haripriya, did you remember?
Come again.
See, what was the necessary condition? See, that's what I'm telling. Don't know how you are applying the concept. You do not know when to apply the concept. If at all they give you some question uh, which will be changed, is the new question if they will give you, you won't be able to solve. It's guarantee 100%. I can sign on it. You won't be able to solve. If a good quality question they put forward, you won't be able to solve. You won't know only how to when to apply, when to put the law of conservation of momentum, when not. This is a question which is already asked in 2021. Either you would have seen on internet or you would have seen on in some book. That's why you are able to apply the law of conservation of momentum. You do not know the necessary condition for applying the law of conservation of momentum. How you will apply it? The basic condition for applying the law of conservation of momentum is there should not be any external force acting on it. Only conservative forces should be acting. There should not be any force. When I was teaching, you were not listening there. See, I gave the condition. When F net is equal to 0, impulse is equal to 0. I have explained it very properly. When this F net is equal to 0, this impulse is equal to 0 on the system, then only you can apply the law of conservation of momentum. Because in your FITG, whenever they taught you, they never told this condition. That's why you are not able to remember this.
So they didn't cover conservation of momentum yet.
But I have covered. But if they did not cover, how you are able to apply the conservation of momentum? How you got the idea? You saw it in the net, internet.
No, sir, I saw it.
Then how did you get the idea?
So because the particle is being split into two pieces, so the final and initial will be same.
Achha, you know this part. When particle is split into two pieces, you have to apply law of conservation of momentum. That's all.
No, sir. Like we've solved a lot of problems, so I got practice to it.
Where they have solved?
No, sir. In my ninth and all, we used to solve the same thing.
In ninth?
Yes, sir. In Fiji.
But means they have covered this conservation of momentum earlier in your ninth class.
Yes, sir, but it's been long time. No, so I forgot the
See,
condition.
what I'm telling, na Shama, you should have the idea. Again, it's up to you. Whatever way you want to study, you study. But later you don't tell me, sir, I'm not able to perform well. Because you're not focusing on the basics. And I have repeatedly told you, you won't be able to solve the question unless you know the basics. You, whenever I ask you, see, in the last time also, I gave this question. You told me, sir, I know how to solve it. We have done in the class itself. But when I asked you how to solve it, what is the answer? You were blank. You were looking at some of the books. You went for 2 minutes, 2 minutes gap, but you could not give me the answer. This is very bad practice.
No, sir.
If you know the answer, if you know how to solve it, just solve it and give me the answer.
Maybe 36.
Don't know what is this practice you are following. Acha,
Maybe
see,
36.
whatever you want to do, you can. You are independent to do. I don't have any say in that. It's your life. What you want to do, you follow. See, how we'll do it. Law of conservation of momentum will be applied. Law of conservation of momentum will be applied because there is no force acting on this. Why no force is acting on this? Because here, when this particle will explode, it will explode into two pieces. One part this, one part this. So when it is exploding, the force will be acting here, force will be acting here. But these two forces are equal and opposite, they will cancel each other. So there are no net force acting on this system. We are taking two balls as a system. No net force is acting, F net is equal to 0. So you can apply the law of conservation of momentum. One part is clear. Then what we'll do? One part is clear, you can apply the law of conservation of momentum to find the velocity. Then
So after that, we could use kinetic energy formula.
then it is easy to solve. Just solve and then give me the answer.
So 36.
No, wrong. X is not 36.
So will it be 1?
Wrong.
Which
So fractional change means like with respect to one or the other, or like the ratio, sir?
They have asked the value of X. That's all. You have to give me the value of X. Fractional change means you have to divide the kinetic energy. Kinetic energy final by kinetic energy initial. That's all.
So is it 3?
No, wrong. See, you said you solved it in the class.
Yes, I solved it, but I should check my working also. Not every. I'm checking my work. Okay, 10, 20 meters. So 9.
No, wrong.
So can I send my working?
Send me.
So in the group or
In the group, you can send. No problem. Acha, you have done 40m is equal to acha, m by 2 into 30 plus by 2 into Arey, why did you take 60?
Isn't it
Huh.
half mv square? He's just written mv.
No. It's conservation of momentum. Initially, why did you write Shyama 60 here? M by 2 into 60?
so because they've given the one of the part moves at 60 meter per second in the same direction.
Acha. Okay. I wrote it wrong. M by 2 into 60. So you've got m by 2 to 30. 30m. 10m is equal to m by 2 into v. So 20 is equal to v. 20v is 20 you have got. Okay. Now what you have done, Shama, here? Half m by 2 into 60 square.
So kinetic energy, no sir.
This they are not asking. Fractional change means final kinetic energy T.
So that's what I asked. So like what should I like the ratio or
No. I
the
said na that final kinetic energy by initial kinetic energy. Final kinetic energy is of these two masses.
oh okay. So
60.
then
This is m by 2 into your 20 meter per second that you have got the answer. 20 is equal to x. Total
so I have
kinetic.
to add both and divide by the first.
Divide by the
I
first.
get it.
राधिका ने क्या है 20 आंसर तुम्हारा भी आया है 60 स्क्वायर प्लस हाफ इंटू 1 बाई एम कहाँ गया फिर m by 4 इंटू 20 स्क्वायर ठीक है नहीं राधिका नहीं you did not have to take you need not have to take the change in kinetic energy delta k you have to just find out the value kef final kinetic energy total divided by initial kinetic energy total you have to take the ratio that's all that's why you are getting wrong answer
1000 by 800.
हाँ तो 5 by 4 आएगा तुम्हारा
Okay. So x की value 5 होगी.
I'm getting 4/5.
Then in that case I think you have done initial kinetic energy by final kinetic energy
Oh,
Sir,
then
I
it'll be
got 3 by
5/4.
हाँ
5/4.
what Haripriya हाँ correct now you are correct
Okay.
now what you are getting Haripriya 3
Yes, sir.
it's easy na half into m by 2 into 60 square plus half into m by 2 into 20 square Okay, so this is the total kinetic energy, and this you will get as 800, I think.
Yes, sir.
1000 m. And initial kinetic energy is
Sir, fractional changes kinetic energy final by kinetic energy initial. Okay.
half m into 40 square. This is 800 m.
Sir, we get 5 by 4.
Hmm.
Sir, I didn't know what was fractional change in kinetic energy.
That's why I told you, na. Achha, this is a good one. This question is good. Try this. So first, try to understand this question. Question is like this. See, up till now, I'm dealing with the basic level of questions only. They are not very tough.
This
If
is
you,
question similar to the length question, right? The chain toppling over a plate.
this is chain question, and there
Sir,
are what, Haripriya?
sir, when you represent length of the chain, sir,
Hmm.
is it m dash into length is equal to m or m into l? M by l is equal to m dash.
No, they did not give. They have given the total mass, no?
No, sir, they have given that 2 meters laying on the table, no, sir.
Acha.
The mass
So,
of 2 meter.
see, in that case, I'll tell you how to find out the mass. See,
The
the chain
linear mass density you have to use. That is that
mass
was
per
mass
unit length.
by
Mass
mass per unit.
mass
Linear
per
mass
unit
density.
length.
Actually, the normal derivation for this will be mgl by n.
There is no need of any derivation, Shyama.
In class, I mean, in Cengage also there was this problem that I solved it. And solved example was there. Not the
See,
same question, but with variables, the
o-
solving was done.
okay, you can do by using variables also. That's not a problem. But here, there is no need to follow any derivation. See, let me explain you the question. A uniform change, whatever way you know how to solve, you solve like that and then get me the answer.
Okay, sir.
A uniform chain of length 3 meter and mass 3 kg overhangs a smooth table with 2 meter lying on the table. See, the total length of this chain is 3 meter and 2 meter is lying on the table. The mass which is present here, it is 1 meter. Now here, if you want to find the mass of this upper part, this part, how you will find? You have to take mass per unit length. Total mass is 3 kg. 3 kg divided by 3 meter. So it will be 1 kg per meter. Mass per unit length. So for 1 meter, the mass is 1 kg. For 2 meter, how it will be? This is 2 kg. And this mass is 1 kg. KLP understood how you take the masses.
Yes. Yes.
Now here, whenever you are trying to find out the potential energy or something, in the case of chains, you have to consider the mass which is present below it or above it. Achha, just try to solve it. Let's see how you can do it. What you will think. Try solving by yourself. One more thing is, Haripriya, whenever you are trying to find the potential energy, na, for the mass, you always consider the mass is present at the center of the chain. Means the total mass, this is the concept of center of mass. Whenever mass is uniformly distributed, in the later chapters in the center of mass, you will study whenever there is a rod uniform mass and length, its mass will actually appear to be present at the center. That's known as the center of mass. So we assume, tell me.
So will we take out the initial potential energy and final potential energy too? Okay. And सिर्फ work energy theorem क्या था इसको वापस बता दोगे?
Work energy theorem is total work done is equal to change in kinetic energy.
हो गया क्या मेरा?
हो गया? क्या है आंसर?
तो मेरा आ रहा है 40.
सही आ रहा है, करेक्ट है.
मैंने सेंटर मैंने पहले जो हैंगिंग पार्ट का था उसको डिवाइडेड बाय 2 कर दिया और फिर जो फाइनल के लिए था उसकी जो लेंथ टोटल थी उसको डिवाइडेड बाय 2 कर दिया.
हाँ, करेक्ट. मतलब you are assuming
मैंने माइनस करा था पहले.
You are assuming the
minus
mass
two
is supposed to be at the center of the hanging part.
Yes.
That's the concept of center of mass. For a uniform mass distribution, the mass actually lies at the center for uniform bodies.
Well, I could find the change in potential energy. How to find the kinetic energy?
Acha, tell me one thing. Can you apply the law of conservation of energy here?
Yes, sir.
Because there is no external,
No force.
non-conservative force acting, because friction is also not there. Then can you find out, since you have found out the change in potential energy, will you be able to find out the change in kinetic energy? Yes, no? Because initial potential energy initial plus kinetic energy initial, which is actually 0 because initially it was at rest,
Yes.
will be equal to potential energy final
Yes.
plus kinetic energy final.
Yes, sir.
Okay, no? So kinetic energy final, you have got it.
40.
Very good. Acha, Kanishka,
Yes, sir, I also got it.
you got now? Initial potential energy is your 1g into half. Final potential energy is what? Acha, I'll find out the difference. Initially, it was here. Now the final condition will be the whole chain will come like this. 3 meter length. So this distance will become 3 by 2, where the mass is. So the difference of the heights will become the potential energy. That means mg into 3 by 2 minus half. So what is mass? 3 into 10 into 1. I'm getting 30.
30 नहीं आएगा इसमें कुछ गलत हुआ मतलब
What I'm doing wrong? See what I'm doing wrong. Initially, the mass which was hanging was only 1 kg. But finally, when the total mass came here, the mass has become 3m, no? 3 kg. That's the mistake I am doing. Initial potential energy was 1 into g into 1 by 2. Final potential energy is 3 into g into 3 by 2.
Sir, wouldn't it be minus mgh?
That's what, no?
No. For the initial potential energy would be negative. The final would be positive. You'll get minus of minus. Or else
No. Initially, the potential energy was this, no? It was here. Mass was 1 kg, mg into, say it is h1, mg h1, no? We are trying to find out the difference in potential energy, that's all. If you take this as the datum, you can take, if you are taking the top point as the datum or the reference point, then it will be minus. And this will be minus of minus, okay? This thing you are telling, no?
yes.
Both are same thing. So it will be minus 5 and this is plus 90 by 2. So it is 45 minus 5, that is equal to 40. like that. It's up to you what datum or what reference point you take. I was taking the bottom, but if you want, you can take the top one. Okay, then, so let me give you one more question. Then try solving this question.
Can I take the question for homework if possible?
Homework only. You can leave. I'm just putting the homework question, that's all. Try doing this. Take it as a homework. Solve it at home. And keep doing the tougher questions from the previous year question book that I have told you. Whatever book you follow, Shama, I'm telling you, whatever book you follow, either your FitG modules or your this one, DC Pandey or some other book or Sengate something, but initially you should try to cover the previous year question book, because most of the questions in your JEE main and JEE advanced will be asked on that only. So first try to cover those.
Yesterday only I bought the books, like again.
Okay.
48 years.
Then
I'll start solving.
I'll start means for every topic you have to follow this trend only. Try completing the question, previous year questions first, then you can move on to your those parts, 10 gauge and all.
Okay.
Okay, then
Yeah.
let's end the class.